All right, let's look at another topic, the rows of a function. So we need certain pieces to come together, and the one is the zeros. So what is a zero? A zero is a number that causes the output of a function to be literally zero. The constant k is a zero if f of k equals zero. Wait, is that a zero the x-intercept? No, no, it is not. So let me draw a graph here. So let's say this is at 2. This is over here. I'm going to go to -4. And we have a graph that touches, so I guess my small because it's kind of parabola looking thing. Great. Now the ordered pair here is, and let's say this is f of x. This ordered pair is going to be negative, sorry, not negative, 2, 0. And the other one here is going to be -4, 0. So what we have is this, f of 2 equals 0, f of -4 equals 0. So 2 and 4 are the zeros of this function. But these are not the x-intercepts. The x-intercepts are -4, 0, 2, 0. So you might have experienced sometime in your past when they were asking for the x-intercept, that maybe you had a textbook or something, other format, and all it listed was -4 into the x-intercept. Well, they were just trying to be friendly and nice, but the reality is that those were not the x-intercepts. Those were the zeros. But they were assuming that you can put all of it together as an ordered pair. So -4, 0 is an x-intercept, so it's 2, 0 as ordered pairs. But again, these numbers here are the zeros. So for example, if I'm giving, this is a polynomial, you notice I got powers here are all positive integers and the base is the variable. So if I want to find the zeros of this, what I'm looking for is what causes the output to be 0. And yes, it's that same thing. When you were asked to find the x-intercepts, you're basically being asked to find the zeros. So when I do that, I'm going to first try and factor this. I have a common factor of x, so I'm going to take that out. And I'm hoping I can factor this. And this is the interesting part about finding zeros. I have to be able to factor or some other method of finding them, but sometimes that is not possible. So I'm going to go for -4, +1. I check 1 times, that's not going to work, is it? So notice again, I can't, that doesn't work. 2, 2, I have to make this, something, I'm going to cheat. Make this -4. Does that work? Let's make that -4. Factor it out. And now that's going to work. So 1x, 4 times -4 is -4x. So I got just a quick check. That's +1. I got -4x. Add them together, I get -3x, which is the middle, and that does work. But let's factor into that. So to find the zeros, I set each one equal to 0 since I have a product. The only way a product can be equal to 0 if it's one of the factors is equal to 0. So I want to find all zeros. I'm going to set all of them equal to 0 and solve. So here when I solve, I get -1 and set the other one equal to 0. When I solve, I get equals 4. So the zeros are 0, -1, and 4. Those are the zeros of this polynomial. Find the zeros of the function g of x equals blah, blah, blah. And again, notice this is a polynomial. It's in semi-factored form. So if I were to distribute and add like terms, I can make it look like this format right here. But I want it in factored form anyway, so this is nearly factored. I see a common factor of x minus 4, so I'll factor that out. And when I factor that out, I have x plus 5. I recognize this is a quadratic, so if I want to find the zeros, I will set this whole thing equal to 0. And solve, and again, just like before, the only way that product can be equal to 0 is if one of the factors is 0, but I want to find all solutions, so I'm going to put both of them equal to 0. So x minus 4 equals 0. Add 4 to both sides, I get 4. Here I got x plus 5 equals 0. Subtract 5 from both sides, I get x equals -5. So the zeros are 4 and -5. If you were to ask for the x-intercepts, that was the question, then the x-intercepts are 4, 0 and -5, 0. So the x-intercepts are, it's a point on the graph, so therefore I have to write an ordered pair, but the zeros are one of the components. Again, the 0 is the thing that causes the output to be 0. So g of 4, that produces 0. G of 5, that produces 0. And that's why these things are the zeros of the function. And again, just to check, if you don't believe it, let me just enter g of 5 here, check one of them. So that means everywhere here I'm going to enter a 5. I see a variable. So here I have 5 minus 4. Well, it's -5, sorry. It should be entering -5, -5, -5. -5, -5 here. So I got -5 plus, or some -5 subtract 4 is -9. And here -5 subtract 4 again is -9. So I get 45 plus -45, and then d, that gives me a 0. And I can check the other one, but I won't right now. And those are the zeros. That's all a 0 is. The 0 is a number such that f of that number equals 0.